How's going on, everybody? Welcome to part 2 of learning neural networks from scratch using C++ language. So this is part 2 if you haven't saw part 1, because in that we have learned what are neural networks and how the input value is get processed to become the output value. And in the part 1, if you remember, I have given you brief introduction of what are activation functions, and in this video we are going to see what are activation functions, why do we use them, what is the use of it, and how do we code them manually from scratch. So I hope you all might be interested in it. So let's just directly dive into the video. So over here on the screen, as you can see, it is a function which is applied to the input value, which is weight times input plus bias. If you can't understand this, let me just show you quickly. Alright, so over here in front of you, here is a very simple neural network with only single input layer and two output neurons. Let us say that the input value is x. So the input value is x, which is this input neuron, and the output value, let us say this is y1 and y2. Now if you remember, every node has weight assigned to them, let's say w1 and w2, and bias, particular bias of them, let's say b1 and b2. Alright, there we go. Now if you remember, y1 should equal to, if I am not wrong, y1 should equals to x times w1 plus b1, which is times weight plus bias. Now I have told you in the part 1 that this whole value will going to get transferred through the activation function, and this is what we are going to talk about today. Now why do we pass this value through the activation function, and what this activation function actually do to the value? Plus we will see what are the different types of activation function and where do we use which activation function. So let us see that. So over here on the screen, you should see three activation functions which are non-linear. So activation function is of two types, linear and non-linear. Linear is just simple, whatever the value, just pass it as it is, which is we are saying we are already seen this activation function in the part 1, because we are not doing anything with the value. So this is the linear function. We are not doing anything with the input value, that is linear function. Now we are going to talk about sigmoid, Tanh and relu function, plus we are going to talk about softmax function. So let us first see what is the use of activation function. Now I'm not going to tell you once again what y1 will going to look like, you already know that. Now if we use no activation function, then the probability is that y would range from minus infinity to positive infinity, meaning y can contain any value between this particular range. Do you agree with this or not? Obviously you should agree with this. And so this creates problem in the neural networks, because y1 should have some boundaries and y2 should have some boundaries to be a particular value in a particular range, and this is what the activation functions are doing. Let us see the activation functions. So as you can see in the sigmoid function, that the value ranges from 0 up to 1. And if you see the Tanh function, the output value from this function ranges from -1 to +1, and output value from the relu function ranges from 0 up to positive value, whatever it is. And similarly, softmax function is just a different type of function. We will talk about it later on, but first we should focus on sigmoid, Tanh and relu. So now I guess you should know why do we use activation function, right? We use activation function to make the output value between some boundary, just limit the output value. Otherwise the neural network could have blown up the values with the values like minus infinity could be any negative value, plus infinity could be any positive value. Now this would just blow up our neural network. So I hope this should be enough about activation functions. One more thing I would like to tell you about activation function, that as the name suggests, activation, just it decides when the neuron should get fired, when the neuron should get activated, and only the neuron can't even decide what value, what boundary value should it get inside it, because neuron is just a variable which can hold a value. I have already told you about this. So we use activation function to tell the neuron like this particular value you should have in yourself. Plus activation function helps neural network to fire particular neuron at particular input value. I hope this should be a lot about activation function. Now let's just directly code the activation functions. So I'm going to use code blocks once again. So if you remember, this is the code from part 1, and these are 2 input neurons and 3 output neurons and 6 weights and 3 biases, obviously because we have 3 output neurons. Now I have a question for you, where we are going to apply activation function in this matrix multiplication code. So we are going to apply activation function over here. So let me just create a comment, apply activation. So we are going to apply activation function over here. Why? So obviously because this is the sum of input times weight, and this is sum plus bias, and we have to apply the activation function to the input directly, weight times input plus bias, and this is over here. So let us first start by creating a function called sigmoid function. You know what, let us first create linear function. So we'll create a comment and we'll say linear function, and we are going to create a function. So it is going to return the value which is of floating type or double type, and we are going to say linear, and it is going to take a value of double type, let's say x, and it is just going to return x. Yeah, this is it, linear function. And let me just quickly show you, if we apply linear function, as I said, we are going to apply function over here. So we'll do something like this. So now if we run this code, then you can see the outputs are 1.7, 2.4 and 2.5. If we run this without linear function, then the outputs are 1.7, 2.4 and 2.5. So we are going to use linear function because it doesn't making any difference. Now you might ask a question, why do we use linear function if it is not making any difference? Basically we use linear function in the linear problem and non-linear function in the non-linear problem such as classification problem. So linear function, we don't use it oftenly. You would never going to use linear function a lot of times. Maybe that would be just a particular time when you will going to use linear. Like you can use linear when you are creating a neural network to predict the next digit, or when you are creating a neural network to predict sum of two numbers. So in that way you are going to use linear functions. So now we are going to proceed further by creating sigmoid function. Before creating sigmoid function, let me just show you how sigmoid function looks like. So this is the sigmoid function. Let me just do this. Yeah, this is the formula for sigmoid function. It is 1 divided by 1 plus exponential of negative of the input value. So we are going to use math library. So we'll include math.h. If you don't know how to calculate exponential, you can consider watching videos for that from Khan Academy, from YouTube. There would be already so many videos, but we are going to use math.h library. So we'll say double. Again, double is the return type of the function, which is it is going to return double type of value, and we are going to say sigmoid. It is going to take a value, let's say double x. What we are saying is that we are creating a function which is going to return a double type value, and it is going to take in x value which is of double type. So what this will going to return is this, return 1 divided by 1 plus, let's just 1 plus exponential of negative of x. That is it. Let me just double check it. 1 divided by 1 plus exponential of negative x. Yeah, that is it. So let us apply this sigmoid function over here and see if it works or not. Yeah, this is the output from the sigmoid function, which is 0.8, 0.91 and 0.92. Let us create Tanh function. Like Tanh is just very easy to create. Let's first create it, and then I will tell you about sigmoid and Tanh function, what is the difference in between them. So double Tanh, it is going to take input of type double, and it is going to return Tanh of x. And if we do it like this, run this, and we got an error. Oh, we have to rename this function because Tanh is already available. Let's say Tanh func. Okay, we got the output, which is 0.93, 0.98 and 0.98. Now let us see the difference between Tanh and sigmoid function. Okay, so as you can see, let me just change the size. So as you can see the diagram of sigmoid function, the sigmoid output value ranges from 0 up to 1, whereas the Tanh function output value ranges from -1 to +1. This is the main difference between sigmoid and the Tanh function. So what is the difference between sigmoid and Tanh? First difference is the output value ranges from 0 to 1 and -1 to 1. Now the sigmoid function is basically mostly used in classification problems. Similarly, Tanh also used in classification problem. So in the upcoming videos, when we'll see back propagation, then you will see that the zero part creates the problem, because when we calculate the differentiation of value close to 0, it becomes 0 0 0, and suddenly our network becomes dead. So for getting out of that error, we basically use Tanh function, but it doesn't make a lot of problems when you just use sigmoid as the output layer. Yes, most of the people use sigmoid as just the output layer and Tanh also just the output layer, but mostly people you will see is that they are using relu as the output layer. Let us see how relu works, and we are going to then code it. Well, relu is very simple, very simple. It is just max of 0 or x. X is the input value and 0 as we got it. So if we pass x as negative value, it is going to return 0. If we pass x as positive value, it is going to return x as it is. It means for positive of x, it is going to show the linear behavior. For negative of x, it is just going to return 0. So let us calculate or code that. So we'll say relu double relu, and it is going to be x, and we are just going to return max of 0 and x. Let's try running this if max works or not. So we'll change this to relu. So we got an error. You know what, we'll create our own max function. So we'll say double. Okay, so I have created a function called rmax, and we check if the x is less than 0, return 0. It means it's negative. If x is greater than 0 or equals to 0, return as it is. And we are calling this rmax function over here, and we are going to do this. So let's try running this and see if it works or not. So the output, you can see it is 1.7, 2.4 and 2.5, because our output value all are positive. So it will going to show us linear behavior. Otherwise, if the values were negative, then it should give us 0. Okay, so I have tried to manipulate with that, and I have changed both the input values to -1 and -3, and if we run this, then you can see the value is 0.3, 0 and 0, because the output should be negative, so it just changed that to 0. So the last function I would like to talk about is the softmax function. Softmax function, you just always going to use this function as the output layer, and you are going to use softmax function if you are going to do multi-class classification. So let us first see how this will going to look like, and then we will code that. Alright, so this is the softmax function, and as you can see, this is the output layer. These are the values inside the output layer, and these are changed to probabilities, which is right over here. And as you can see, the max value has the max probability, which is 0.9, and the least value has the least probability, which is 0.01. Now what this softmax function is doing is that it is just mapping all the values to the probabilities, all the values to the probabilities, all the values to the probabilities. So as you should get the point that the softmax function is going to be used in the classification problem when you want the confidence, the particular prediction confidence of a particular class, then you are going to use softmax function. Now how this basically works is that first we calculate exponential of each value. It means exponential of 1.3 plus exponential of 5.1, exponential of 2.2, exponential of 0.7 and exponential of 1.1, and then you just sum them up, and then you divide that, like you have the sum, right? Let's say this is the sum. Now if you want to calculate softmax of 1.3, then you will just divide 1.3 by the sum. That is it. So let us see through coding. Okay, so we are not going to create separate function for softmax function. We are just going to code it inside the main function. Why? Because we have to pass full array, and later on we will see it. But for now, keeping things simple, we will just do it over here. So we are going to first say we will have a variable called allSum, or let's say exponential sum, and it is going to be 0. So we'll run a loop for int I 0 less than number of output neurons is 3 and I plus plus, and we'll say sum plus is equals to exponential of output I. Okay, so this is going to contain this particular part, which is sum of all the output values. So for predicting, we will just directly show them. We say for int I is equals to 0. Yeah, that is it. I don't know if you have noticed or not. It should be exp sum, not sum. So let's try running this first. Let us give the space cout. Okay, so the output of the softmax value of these values is this one. Okay, so if we run it like this, there is some problem. Actually, it should be exponential of it. So it should be exponential of this, as you can see in the formula, exponential of z. So if we run it like this, then you should see the probabilities like 0.19, 0.38 and 0.42, because 2.5 is the largest value. Now if this is the probability distribution of the values, and if we do the sum of all these three, it should be equals to 1. So if we do it, then you can see it is 0.9 and 9, which is close to 1. It means it is actually mapping the values to the probability. Now I guess this is it for this video. And if you have any queries regarding this video, you may ask them in the comment section. And you can also follow me on LinkedIn. You can talk to me on Discord if you want to, and you can talk to me through Facebook pages also. And this is it for this video. I will see you in the next part. Bye bye.